Alright, I got a Lidmotor penny oscillator, slightly modified, and I got this other guy over here, the penny oscillator variant with the telephone wire. And this guy right here is probably a lot more efficient, but he's got a 6800 microfarad cap. Just got one high power 3-volt LED and a 150 ohm resistor on the base instead of a 100 ohm. Other than that, I believe the coil is the same kind of wire. It's pretty much garbage tie wires the way they were selling it. But when I bought it, it was like $9 for both of those. And this guy here, he actually does not have a capacitor. Instead of a capacitor, I used a very old lithium button cell from a garden light, and the cell had went bad and just would not contain the same amount, just did not have the same amount of amp hour capacity, milliamp hour capacity as it was supposed to. So it acts more like a high farad cap, I would say, but it doesn't want to go out. The light here is still just slightly blinking. If I can actually see what it sounds like. Sounds like a cricket, but he's just barely puttering. And I've been shorting out the battery with these damn strippers here for about 10 minutes, but it just keeps shooting back up in voltage. That's the whole deal with the chemicals in the battery. But at any rate, that's him going. I'll cut him all the way back down. That's that guy. And this guy is not running yet because his capacitor is dead. So to charge both of these guys, I'm just going to use this little AA exciter. And they both have AV plugs connected to their power sources. I'm going to cut him on. See how long it takes to charge him up, and see if I can notice a difference on this guy. Some interesting sounds you can hear in the radio too sometimes. Well, there he goes. So he's probably up to about a little over a half a volt now. But you won't see the light until it gets a little brighter or higher in voltage, and I cut off the exciter because that's interfering with the circuits. That's how it does. This guy right here, cut him up. Yeah, now you can just barely see the light on this guy. battle of the helicopter sounds right there. So now that I can see his LED is pretty decently bright, I'm cut off the exciter. We'll just disconnect these leads right here. What I thought was kind of cool is they affect each other when I have them tuned a certain way. It's not much of a noticeable change now, but I know earlier when he had a little more charge in him and I moved him closer to this guy and he was just barely moving along at maybe a fourth of a volt, or I'd say about 400 millivolts, and when I moved him closer he started blinking. So they were definitely, he was definitely affected by this guy. I don't know if it was just all the presence of the steel or what. That might have been what it was, but definitely very sensitive. So that's him going away. Cut him back down. So that's the copper wire guy, which by the way they are wound different. That is a jewel thief circuit, and then you have another pair of windings that are wound as a bifilar, and then end to end is where the LED is attached to as the load. So that's the difference there. And this guy, still running off that charge that was put in that capacitor, and turn him up. So yeah, these guys will run for a very long time. But according to my meter, this guy was running down at 1.5 microamps. But at that point I could barely see the LED, the light. So that is one thing, I guess. It's about finding LEDs that won't necessarily light at a lower voltage but at a lower amperage, which I don't really have on hand. And I know this guy takes a good deal of juice, and this guy doesn't. That's why he appears to be brighter. So if I had another one of these, then the penny oscillator would definitely be a little brighter as far as the LED goes. But he's still oscillating, and I can see the light blinking, so it is showing me indication there. So that's all you really need. It's not really supposed to be a flashlight, but very cool. Actually is useful to learn about these little low amp draw circuits, because it helps you to understand how to make the bigger ones more efficient. That was pretty cool though.